Okay, here we have a product of two things that are equal to 0. So whenever that happens, one of the factors has to be equal to 0. Or in fact, if either factor were equal to 0, this equation would be true. So we find the solutions by setting each one of these factors to 0 and solving. So we bring this over by subtracting, and we get x is equal to -10. We bring this over by adding, and we get x is equal to 5, and we put our answer in one line like this, -10 and +5, and that's it. The shortcut is it's always going to be the opposite of this because you're moving this over, and this number divided by the coefficient, because if there was a coefficient here, we divide it on each side. So it would be -10 over 1 and +5 over 1. Okay, we have the product of two things is equal to 0, so x is going to be equal to -7 over 1 and opposite of this, -3 over 1. And that's it. Okay, here we have a product of two things is equal to 0, so if this is equal to 0, provide a solution, and if this were equal to 0, provide a solution. So the long way to do it is to set these things equal to 0 to solve. There's a faster way. We bring this over by subtracting, and then we divide each side by 3, and we get k is equal to -8/3. We bring this over by adding, and then we divide each side by 2, so k is equal to 5/2. So k is equal to -8/3 and +5/2. Now, the shortcut is it's always the opposite of this and this number over that. So -8 over 3 and +5 over 2. So you don't have to do any of this work. You can jump right from here to here. Okay, I'm just going to use the shortcut. So if the product of two things is equal to 0, that means that q must be equal to -5 over 2, and the opposite of this is +4 over 3. And that's it. Okay, here this is not in factored form, so our first step is to factor it into a binomial times a binomial. Factors of -10 that add up to -3 are -5 and +2. So we have m minus 5 and m plus 2. So m must be equal to opposite, so +5 over 1, and the opposite, -2 over 1. And that's it. So we'll factor this. Factors of -12 that add up to +1 are +4 and -3. So we have x plus 4 and x minus 3. So x is equal to the opposite of this, so -4 over 1 and +3 over 1. Okay, so factors of +18 that add up to 9 are 6 and 3. So we have z plus 6 and z plus 3. So that tells us that z is equal to -6 over 1 and -3 over 1. Okay, factors of +80 that add up to -18. Well, let's see. They're both going to be negative, and they've got to add up. So -10 and -8. So we have x minus 10 and x minus 8 is equal to 0. So this tells us that x is equal to the opposite of this, that over that, so +10 over 1 and +8 over 1. And that's it. Okay, this is the first problem we've had that's not equal to 0. So that's got to be our first step. Solving quadratic equations, we have to set the equation equal to 0. So we'll move this over to the left, it'll flip to a negative. We'll move that over to the left, it'll flip to the negative. So far we've got 2x squared minus 7x minus 4, and now that's equal to 0. If you want to use slide, divide, slide, oops, I just missed. You slide this over, your 2 over, and you're going to get -8. And we're looking for factors of -8 that add up to -7. So -8 and +1. So we have x, oops, minus 8 and x plus 1 equals 0, but that's the slide part. Now we got to divide by the number we slid over. Remember, don't forget that. So it's slide, divide, slide. The sliding over is this part, then we're dividing by what we slid over, and you reduce the fractions if you can. And if you can't, just leave it alone. Now, normally you'd slide this back if you had to, but when you're solving it, you don't have to, because it's just the opposite of this. So in other words, we're going to have x is equal to positive 4 and negative 1/2. Now you could have slid this back, and if you did, you would get x minus 4 times 2x plus 1. So this gives you x is equal to positive 4 and negative 1 over 2. But we already knew that, because sliding back and then solving it, you'll get the same answer. It's just flipping that sign. Okay, we're going to set this equal to 0 by moving this and this over. And remember, when they move over, they flip signs. So we're going to have 2x squared. I'll move the x over first, so that's positive x, and then I'll move the 3 over so that my terms are in order. And then if you use slide, divide, slide, we slide the 2 over and we get negative 6. So what are factors of negative 6 that add up to 1? Positive 3 and negative 2. So now we have x plus 3 and x minus 2. That's the slide part. Now we're going to divide by what we slid over, which was the 2. And we'll reduce the fraction if we can. So our answer is going to be x is equal to negative 3/2 and positive 1. And that's it. Notice, by the way, you could have gotten there right from here without doing this step. It's the opposite of this and the opposite of this. So, okay, we're going to set this equal to 0 by moving this over. So we'll have 15k squared minus 7k, oops, what did I just do? Minus 4 equals 0. If you use slide, divide, slide, you slide over the 15 and you're going to get negative 60. Factors of negative 60 that add up to negative 7 are negative 12 and positive 5. And you can just run down all the factor pairs till you arrive at that. But now we've got k minus 12, k plus 5. And remember, you got to divide by what you slid over. And actually, you can jump to the answer right from here by reducing the fraction. So the answer is going to be the opposite of this, positive, and then just reduce the fraction. Dividing by 3 gives you 4 over 5. And the opposite of this, so negative, and just reduce the fraction. Dividing by 5 gives you 1 over 3. That's the power of slide, divide, slide when you're solving. You don't have to reduce these fractions and do the last slide over. You just can jump right to the answer. Okay, the first thing we're going to do is we're going to set this equal to 0 by moving that over. And then if you use slide, divide, slide, you'll slide over the 12 and you'll get negative 60. Factors of negative 60 that give us a positive 4 is going to be, let's see, 10 and 6. So positive 10 and negative 6. And then just don't forget to divide by what you slid over. So we're going to have x is equal to negative, the opposite of this. Now reduce the fraction, 5 over 6. And a positive, the opposite of that, and reduce the fraction, 1/2. Okay, for number 15, the first step would be to move this over. Now, it looks like I have a perfect square. And the reason I think that is because this is a perfect square and this is a perfect square. So I'm going to test it. I move the square root of this here. I put this first sign here. and I put the square root of this here. But then I've got to check the middle term. You check it by multiplying these two together and then doubling it to see if you get this. So 4x times 3 is 12x, and when I double I get this. So this really is the answer. And I'm only going to have one answer. It's going to be the opposite of this and this over this. So x is equal to negative 3 over 4. And that's it. Okay, number 16, I'll start by moving this over to set it equal to 0. And now it looks like I have a perfect square. And again, the reason I think I might have a perfect square is this is a perfect square and this is a perfect square. But I've got to check the middle term. So remember, you put the square root of this here, put this first sign here, and then put the square root of this here. But now check the middle term. You got to take the product of these and double to see if you get this. Well, the product of 7x and 1 is 7x. If we double, we get this, so this really is the answer. So we're going to get just one solution. Opposite of this and this over this. Okay, a couple of things going on here. We're missing this third term, but that's okay. These two have something in common. They're both divisible by 2 and by a. So let's factor out that GCF before we do anything else. We're going to get an a minus 4 here. Well, this 2 does not contribute to the solution, but this variable does. We're going to get a is equal to 0 from this on the outside and positive 4 over 1 from this. And those are our two solutions. Okay, again, our very first step in any factoring problem is to take a GCF out. These are both divisible by 4 and by x. So it leaves behind an x plus 4. Now, this 4 does not contribute to the solution, but this x does. This is going to give us an x is equal to 0, and this is going to give us negative 4 over 1. So those are the two solutions. Again, we have a common factor. These are both divisible by 6 and by m. So you take that out, and you're left with an m minus 6. This 6 does not contribute to the solution, but this m does. That's going to give us an m is equal to 0, and this is going to be positive 6 over 1. 20, again we have a GCF. They're both divisible by 3 and by m. So we take out a 3m, and we're left with m minus 9. Now this 3 does not contribute to the solution, but this m does. That's going to give us an m is equal to 0. And this is going to be positive 9 over 1. That's it. Okay, again we have a GCF. There's a 4 that's divisible by both of these. So we take out the 4, and we're left with p squared minus 4. Now, this can be factored. This is the difference of two squares, p squared minus 2 squared. Whenever you have the difference of two squares, you always end up with the conjugate pairs. It's the square root of the first thing plus the square root of the second thing times the square root of the first thing minus the square root of the second thing. So p is going to be equal to, this number on the outside does not contribute to the solution. This gives us a negative 2 over 1, and this gives us a positive 2 over 1. Now, most people will write this, and you could circle that, but most people write plus and minus 2. Although this is perfectly acceptable. Okay, here we have a GCF of 9, so let's take that out. And that leaves behind that. And again, we have the difference of two squares, which is going to give us conjugate pairs. The difference of two squares, it's always the first item plus the square root of the second item, so x plus 3, and then x minus 3. Now, this does not provide anything for the solution because it's not a variable out there. But this gives us a negative 3, this gives us a positive 3, so we can just write it like this. Okay, these are both divisible by 3. Instead of factoring out just a 3, I'm going to factor out a negative 3 because now I'll have a positive m squared minus a 9. And I can see that that's the difference of two squares. So the difference of two squares gives me the conjugate pairs. The square root of this is m, the square root of this is 3. This does not contribute to the solution at all. But this gives us a negative 3, this gives us a positive 3. That's it. Okay, here these are both divisible by 2, but instead of taking out just a 2, I'm going to take out a negative 2. And that's going to leave behind a positive x squared minus a 4. And that's the difference of two squares. So we're going to get conjugate pairs. Square root of x squared is x, the square root of 4 is 2. So we have x plus 2 and x minus 2. Now again, this does not contribute to the solution. But this is going to give us a negative 2, this is going to give us a positive 2. Now if this was equal to 0, we'd be done. We get positive 3 and negative 5. But it's not equal to 0, so we're going to have to multiply this out and then bring this over and then refactor it. So I'm going to FOIL. The first gives me x squared. The outer on the left gives me a positive 5x. The inner gives me a negative 3x. And the last gives me negative 15. Let's bring this over in this step. And then I'm going to bring this over. I'll bring this over, and that'll give me a plus 7 over here. And now it's equal to 0. Now I'm going to recombine and factor. So I have x squared, positive 5 and negative 3 give me a positive 2x. Negative 15 and positive 7 give me a negative 8. So now I can factor this. Factors of negative 8 that add up to 2 are positive 4 and negative 2. So this gives me x is equal to negative 4 from the first one and positive 2 from the second. That's it. Okay, again, if this were equal to 0, it would be a super easy problem. We'd have negative 8 and positive 2 as answers, but it's not, so we're going to FOIL this out and bring this over and refactor. So when I FOIL, the left-hand side, the first is x squared, the outer is negative 2x, the inner is a positive 8x, and the last is a negative 16. Now I'll move this over, so I'll get a plus 21, and now it's equal to 0. So I'm going to combine like terms. Negative 2x and positive 8x give me a positive 6x. Negative 16 and a positive 21 give me a positive 5. So factors of 5 that add up to 6 are positive 5 and positive 1. So we have an x is equal to negative 5 from the first factor and negative 1 from the second. Okay, again, if this were equal to 0, it would be easy. It would be negative 1 over 2 and positive 3 over 1. But it's not. So I'm going to FOIL out the left-hand side and then bring everything over and set it equal to 0. So when I FOIL the left, the first is 2x squared. The outer is negative 6x. The inner is a positive 1x, and the last is a negative 3. And then I'll move this over to get negative 6x, and I'll move this over to get negative 3, and now it's equal to 0. So 2x squared is all by itself. But here we have a negative 6 and a negative 6. That gives us a negative 12. Oh, and a positive 1. So that gives us a negative 11x. There's this one here. So that's a negative 11x. And then here we have a negative 3 and negative 3. That gives us a negative 6. And now that's equal to 0. So I can slide this over. I'm sliding over a 2. And we're going to get negative 12. So what are factors of negative 12 that add up to negative 11? Well, negative 12 and positive 1. That's the slide part. Now the divide of what we slid over. So we're going to end up with x is equal to a positive 6 and a negative 1/2. Remember, you don't have to do, if you were factoring, I'd have to do slide divide and I'd have to do the last slide, bring this over and so forth. But when you're solving, you don't need to bring this over just to divide it out again. So it's just the opposite of that. So the opposite of the reduced fraction here and the opposite of that. Okay, again, if this were equal to 0, I'd be done, but it's not, so I'm going to FOIL out the left-hand side. The first is 3x squared. The outer is negative 9x. The inner is a positive 2x. And the last is negative 6. Now I'll bring this over, so that'll become a negative 7x. I'll bring that over, so it'll become a positive 1. And now that's equal to 0. So now let's combine like terms. Let's see, I have negative 9, negative 6, and negative 7. That's negative 15, negative 22x. And, oh, wait a minute, I have more. Let me undo that. I'll underline them. I have this, 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 and this. Negative 9 and negative, or positive 2 is negative 7. Then negative 6 gives me negative 13. Then negative 7 gives me negative 20. And then I just have that plus 1. Let me make sure I didn't make a mistake there because this is prime. So let's FOIL this. I want to make sure I didn't FOIL it incorrectly. First is 3x squared. The outer is negative 2x. The inner is positive 2x. Oh, this is not negative 6x. It's just negative 6. There, that's my mistake there. Sorry if you saw that earlier and were bothered by that. So I have negative 9, positive 2, and negative 7 give me negative 60, negative 14x. And then I have negative 6 and positive 1 gives me a negative 5 equals 0. So if you use slide, divide, slide, you'd slide this over and get negative 15. I'm looking for factors of negative 15 that give me negative 14. So negative 15 and positive 1. And then I divide by what I slid over, the 3. And then I just reduce the fraction. So I have x is equal to positive 5 and negative 1/3. Positive, reduce this, negative, and that's already reduced. And that's it. Okay, these are all divisible by x, so that'll be my first step. I'm going to divide out my GCF. So I'm going to be left with 2x squared minus 9x minus 5. Now you can use slide, divide, slide if you want. You don't have to, but if you use slide, divide, slide, you'd slide this over and you get negative 10. Factors of negative 10 that give us this negative 9 are negative 10 and positive 1. That's the slide part. Then you divide by what you slid over. So your answer is going to be x is equal to 0 from the outside, a positive, reduce this and you get 5, and a negative 1/2. Now I personally think that's the easiest way to solve these, but you didn't have to use slide, divide, slide to factor this. But I think slide, divide, slide lends itself especially well to solving. Okay, the first step is to take out the GCF, which is x, and you're left with 6x squared minus 13x minus 5. Now, I'm going to use slide, divide, slide. So I'll slide the 6 over, and we're going to get negative 30. Factors of negative 30 that add up to this are negative 15 and positive 2. Now that's the slide part. Now we're going to divide by what we slid over. And we're done. So we're going to get x is equal to 0 from this outside, positive, and reduce this fraction. Dividing by 3 gives me 5/2. And negative, reduce that fraction. And we're done. Okay, this is not set equal to 0, so that's going to be our first step. We're going to move this over. Now we have a GCF, the x, so let's factor that out. Now factors of 3 that give us negative 3 that give us negative 2 are negative 3 and positive 1. So we're done. x is equal to 0, positive 3, and negative 1. 0 from this, positive 3 over 1 from this, and negative 1 over 1 from this. Okay, number 36 is not equal to 0, so that'll be our first step. We'll set it equal to 0 by moving that over. And that'll become a positive 8z on the left. Now we have a common factor of z, so we'll factor that out. Factors of positive 8 that add up to negative 6 are positive, negative 4 and negative 2, excuse me. How can I do this? Negative 4 and negative 2. So we're done. Z is equal to 0, positive 4, and positive 2. 0 from this, positive 4 from this, and positive 2 from that. Okay, this is not equal to 0, so that's going to be our first step. We'll move that over, and it'll become a negative there. Now there's a common, this is a cubed. Sorry, I miswrote that. Okay, there's a common factor of, let's see, just t. So we pull out the t, and we're left with 9t squared minus 16. Well, this is the difference of two squares. This is 3t squared minus 4 squared. So we're going to have the conjugate pairs. Okay? It's the first item plus the second item, and the first item minus the second item. So t is equal to 0 from this, a negative 4 over 3 from this, and a positive 4 over 3 from this, so we can write that as plus and minus 4 over 3. Or you could have written it separately, either way. Number 38, this is not equal to 0, so that'll be my first step. I'll move that over, and I'll get 25x cubed minus 64x equals 0. They both have a common factor of x. This is the difference of two squares. This is 5x squared minus 8 squared. So we're going to have x times 5x plus 8 times 5x minus 8. So this will give us x is equal to 0 from this, a negative 8 over 5 from this, and a positive 8 over 5 from this, so plus and minus 8 over 5. Okay, there's more than one way to do this, but when you have 4 terms, you're going to look to solve a factor by grouping. So I'm going to group these first two together as if they're a separate problem. And I'm going to take out an r squared. And I'm going to be left with 2r plus 5. When you do this, leave a big space and put 2r plus 5 down again, and then think about what you'd have to put here so that when you distribute, you get back to the originals. So it looks like a negative 1. So the common factor is 2r plus 5, and we're left with r squared minus 1. Well, we can't stop here because this is not factored completely. This is the difference of two squares. The square root of this is r, the square root of this is 1. So this is going to be, it's going to factor to the conjugate pairs, r plus 1 and r minus 1. But we still have this. So your final answer is r is equal to negative 5 over 2. This here will give us a negative 1. This here will give us a positive 1. So we can write it like this. Plus, or you could just list out all three, which is fine. And that's it. Okay, again, here we have 4 terms. So I'm going to group it 2 by 2. I'll group these two together and factor it as if it's a separate problem. So I'll pull out the common factor of p squared, and we'll be left with 2p plus 1. So I'm going to leave a big space, and I'm going to put 2p plus 1 down again, because I know that whatever I leave behind here, I have to leave behind here. Then I'll think about what I put here so that when I distribute it, I get back to these. So let's say I need to multiply by a negative 49 to get to this. And I'll just double check. When I distribute, this times this is this, and this times this is this, so it works. Now when I look at this, the common factor is 2p plus 1, so I pull that out, and then I'm left with p squared minus 49. Now I can't stop here because this is the difference of two squares, p squared minus 7 squared. So I'm going to get the conjugate pairs for this. This is p plus 7 and p minus 7. And I still have this. So my answer is going to be negative 1 over 2 from that, a negative 7 over 1 from that, and a positive 7 over 1 for that, so just plus and minus 7. And that's it.